Hey guys, hi, welcome to the session. So, this is Padma Tejaswi, and I have done my master's in chemical engineering from NIT Raoult. So, yeah, how are you? I hope you guys are doing well and your preparation is going on. So, yeah, just a minute. So, I have been teaching for chemical engineering students uh, since 1 year. Yeah. So I guess I'm clear and I'm visible to you. So please confirm me that I'm visible and yeah, I'm clear. So because a lot of times we got this voice is not visible or something like that. So I'm clear, right? Yeah. Okay. So I'm here. I'm previously teaching for GATE Chemical Engineering students since 1 year. So I just thought that the online platform is very good for reaching out to more number of students, right? So yeah, that is why I have started teaching in Unacademy. And yeah, if you like the session, give a big thumbs up, and yeah, do share this video with your friends so that they will also know how to do, how to crack gate for chemical engineering. And yeah, so this session is about yeah, thermodynamics. So basically thermodynamics session is for both chemical engineering and mechanical engineering students. So in that point of view, I have designed the course in an academy app. So in Unacademy app, I have started a course on thermodynamics part 1 and part 2 and part 3. Okay. So in these three parts, I have taken few, different topics like, so I have, so this third part is only for Carnot cycle. So based on this, how many different types of questions we will be getting, or like what is a Carnot engine, how we will be getting this efficiency formula. So all these things we have discussed, all such type of things. So this thermodynamics part 3 is going on. So if you want to take the session, or if you want to listen to if you want to clear your doubts, then you can take the plus subscription. So but if you haven't taken it, so then hurry up, take it by using this code. And one more thing, if you use this code Padma 10, then you'll be getting a 10% discount on the whole price whatever you are paying. Okay, so go through the courses. And yeah, so for plus drop servers, the most important thing is you will be getting test series also. So we have launched test series for all the branches like mechanical. So for chemical it is not there, but yeah, but we have launched a practice session. Means we do give like weekly quizzes will be there. Okay, so weekly quiz will be there. And yeah, so analysis sessions, doubt clearing sessions, and numerical sessions. Especially few numerical courses were also launched like this. In these sessions we will cover all the previous year topics. And yeah, so we'll do all these things. Okay, so if you want, or if you like the session, give a big thumbs up. And yeah, so this course is about, this session is about previous year questions and a few practice questions related to thermodynamics. Okay, so yeah, let us get into the session. So we have, anyway, this is on YouTube, right? So ask your friends also to cover to visit the session. Okay, yeah. So first in thermodynamics, as I say every time, the most important point is you should read the question properly. See, just by looking at this question, you will get an idea that this is a huge problem. We cannot solve this. So just get rid of that such ideas. Okay, because whatever how lengthy is the problem is not matters. What the question they were asking is that what matters the most. Okay. So yeah, let us read the question. So first, my principles while solving questions while solving questions in any topic are: first, read the question properly, and second one is put the data that they have given. Okay, so means write them according to the points in order. Okay, so while solving in exam also, solve it in a, so they will give you a notepad in which you have to do your rough work and all, right? So the notepad will be enough for practicing all the questions. So please do the calculations in an order, so that if you have any doubt at any point of time, if you check it, you should get to know that this is the first step and this is the second step. Okay, because I've told hello Sakshi, welcome to the class. So yeah, I have told this to a lot of students, but they do the same. They will do in a hurry. They will do calculations like here some part of the calculation will be there. Here some part of the calculation will be there. So don't do such type of things. Just take it as now I'm writing in a point wise, right? So do the calculations like that only in a point wise. So if you do that, then after some time also, like if you want to check it again or if you want to check the calculations again, then you will do it. It will be easy for you. Okay, yeah. So first of all, you should read the question, put the data given in an order, and the most important one, dimensions. Check the dimensions. Okay, see, because example is for heat transfer, you will give watts. So what do you mean by watts? It is joules per second, right? So here the units of energy should be in joules and time considered should be in seconds. So most probably in every question, what they give is time taken is in hours. So let us suppose that they have given in hours. So while solving, you shouldn't take in hours. You should convert this hours to seconds, right? So 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So do this, convert time into seconds and then only do the calculations. Okay. So this is important, and yeah, temperatures also. You should consider temperature in absolute Kelvin temperature, absolute temperature, which is in Kelvin. Okay, because see, if this is conduction or convection, then it's fine because it is a temperature difference, right? So in temperature difference, if you use in degrees centigrade or degrees Kelvin, the answer will be the same. Okay, so there, that is, it will be not a problem. But if you are calculating or if you are solving any radiation heat transfer problems, then there will be T power 4, T1 power 4 minus T2 power 4, right? So here you should use in Kelvin scale only. So follow these steps, and yeah, next one, put the formula. So if you don't know what are the formulas that to use in this particular problem, then from the given data and from the given question, you will have the idea like about which type of question, which type of problem or formula we should use. Okay. So yeah, let's get into the question. A gas obeying the Clausius equation of the state is isothermally compressed from 5 megapascals to 15 megapascals. Okay, so this is an isothermal compression process. So what do you mean by isothermal process? So first I am putting the points. Isothermal process. So isothermal process means temperature should be maintained constant, right? And initial pressure, they have given that initial pressure is 5 megapascals, which means 5 into 10 power 6 pascals, and yeah, so P2, it is finally compressed to 15 megapascals, which is 15 into 10 power 6 pascals, right? Yeah, and it is in a closed system and temperature is 400 Kelvin. So note down the temperature. As it is an isothermal process, yeah, very good Sakshi, delta T is equal to 0 for an isothermal process. Yes. So we have a Clausius equation of state. So they have given the equation also, which type of equation you should use. Okay. So from this we get P is equal to RT by V minus D. Right? So they have given that B of T, which means B is a function of T. Okay? It's not B into T, it is B as a function of T. So where P is the pressure and T is the temperature, V is the molar volume and R is universal gas constant. So the parameter B in the above equation varies with temperature as, so they have given the value of B also. So it is B, which is a function of T. So B of T is equal to B naught plus B1 into T. Right? Is it? Yes. And we also have B naught value. So they have given B naught and B1 values also. B naught is equal to 4 into 10 power minus 5 meters cube per mole. Yeah, the units are really important. So B1 value also they have given. What is B1? 1.35 into 10 power minus 7. So 1.35 into 10 power minus 7. So tell me what will be the units of B1? What could be the units of B1? From B naught you can say what are the units of B1. How to calculate these units, how we can see that these units. We are adding two terms, right? So when we are adding these two terms, they should have just a minute. So when we are adding these two particular terms, the thumb rule is they should have the same units. Okay. So that means the units of B naught are equal to B1 into T, which means meters cube per mole is equal to B1 into Kelvin, because the units of temperature is Kelvin, right? So the units of B1 are meters cube per mole Kelvin. Okay, so these are the units of B1, and yeah, so we have put all the data, and what they have given, the effect of pressure on the molar enthalpy H at a constant temperature is given by. So this is the effect of enthalpy, and Hi and Hf denotes the initial and final molar enthalpies respectively. So the change in the molar enthalpy Hf minus Hi for the process is. Okay. So the change in the enthalpies we should calculate for a particular temperature. Okay. Yes. So the effect of pressure at molar enthalpy, and they have given that at a constant temperature. Okay, means the temperature should be maintained as a constant. So if you maintain a constant temperature, how this equation will be changed? I mean, this is the term, right? So the effect of pressure on the molar enthalpy at a constant temperature. So that means dH dou H by dou P at constant temperature is the value that we should calculate, right? So according to that, we should get these terms. We know volume and temperature. We got that, right? So from this equation, we should calculate dou V by dou T at constant pressure. Okay. See, just for reading the question, we took this much time. But if you practice more such type of questions, you will be able to solve this type of questions very easily and at a very fast way. Okay. So as I'm explaining it to you, I'm taking this much time. But in your exam, you have, yeah, online classes will be there. So, but you have to take a plus subscription for this. Okay, so plus subscribers basically. Okay, I'll just give you the code. Okay, so in Unacademy app, we have an app called Unacademy. I guess you know what is Unacademy app, right? Yeah. So in Unacademy app, we have a plus subscription. Okay. So in that, if you take that subscription, you will get all these types of courses. And no, it's not Vedantu app. Vedantu app is for IIT JEE and all. This is Unacademy Plus. So go to the Play Store, and if you search Unacademy, you will get an app for educating. Okay. So if you go through this app, there will be an option called Plus subscription. So if you take that subscription, this courses and or with along with I didn't understood Tejas. So if you install this app and if you take the subscription, then you will be able to. I mean, then you will get uh, all these courses, and you will also have test series and practice session also. Practice session means, see, you can select few types of questions, like which type of question you need and all. Okay, so you can have that option also. Okay, Sakshi. So, like there is an offer. So, if you use this code Padma 10, then you'll be getting a 10% discount. So, we have 3 months course and 12 months course, and I mean 24 months course also, means 2 year course also. So, whatever you need, you can take that. Okay, yeah. So whatever the subscription you need, you can take it. And yeah, I prefer you guys to take this because you can have this courses like this. You have a lot of courses, not only me. We have all the top educators, and we have other, like we have for chemical engineering, and yeah, I will also be there, and other teachers are also there. You have Gaurav Srivastav, and you will also have Ajay Pratap Singh. So like a lot of educators are there. So just by following this uh, data, and by following this sessions like this, you can go through them. Like if you follow them, you will get a notification that they are going to take the course. Okay. So you are aiming for this year or next year. So if you are aiming for gate this year, that is also fine because you have 1 month, right? So within this month, you can practice a lot of. Okay, yeah, very good. So don't forget to use the code Padma 10 because you will be getting a discount, right? So use that and avail the benefits. We are going to start, and we also have free mock test series. Okay. So Sakshi, don't forget the name. An Academy. It is okay after the end of the. I mean, okay, next year. Very good. You have started your preparation very advanced. So that's a good thing. And yeah, so do this. Then I would suggest you to take a year long subscription. So it will be, oh wow, you are in second year and you are preparing from second year only. That's a very good thing, Sakshi. So do that. It is very encouraging because you'll have a lot of time, like 2 years time you have. That's a huge time. So I guess by the end of the final year, see, I mean by the end of 4-1 semester, you will be clear with all of your. I mean, you will have no doubts, and you will be clear with in theoretical part, whether it is numerical part, everywhere you will be very clear. Okay, so get the subscription, And yeah, so if you have any doubts like how to take the subscription and all, you can post a comment over here, then I will guide you through this. Okay. Yeah, okay, Sakshi. Then let us go to this next question. So we have given all the data, right? Yeah. So from this, what we should get? Yeah, we should know what is dou v by dou t at constant t, right? So for calculating this, it means volume should be a function of temperature and pressure, right? We have this equation. They have given that the dependence of the equation as follows, right? So now, just a minute. So P is equal to RT by V minus B. So if you rearrange this equation, what you'll be getting? RT by P. So volume can be given as RT by P plus B, right? So volume as a function of temperature and pressure. So this is the volume which is a function of temperature and pressure. And yeah, by using this, we can calculate dou V by dou T at constant P, right? So, and we also have, so B is not a constant, right? So B is variable. It is varying with respect to temperature. So you should substitute this value also. So which gives B is equal to RT by P plus B naught plus B1 into T, right? And here we are maintaining a constant pressure. So this pressure is constant. And so dou V by dou T at constant pressure is R by P plus, so B naught is a constant, right? So this will be 0. 0 plus B1. So dou V by dou T at constant pressure, we got this as the value, which means R by P plus B1. So till now, is it clear, Sakshi? Do you have any doubts regarding this? Okay. So let us move forward. So we got this value. We got this value and we know what is V and we also know what is T, right? So now let us write this. So as they discussed or as they required, dou H by dou, just a minute. Yeah. So dou H by dou P at constant T is given as, you were in second year, right? So that is why it will be a little difficult for you, but it's good that you have started your preparation now only. So yeah, a concept will not be clear, but see, Sakshi, when you start your preparation now only, so just do one thing, start your preparation with previous year questions. Okay, so I will suggest you to start your preparation with them, because if you start them, then like you will have an idea, right? So how, I mean, from which topics you are getting, or like what is the percentage from thermodynamics, on which concept they are concentrating more, right? So you'll have an idea. So that is why I'm suggesting you to take it now, because if you wait for 1 year, I'm telling you, you will think that at the end of the third year will start, but you'll have no time left for you, because at the end of third year you'll be having this placements and yeah, another semester exams and project, everything will be there. So that will be like a very hectic. So the class will be for 1 hour. The session is for 1 hour. So yeah, for another half an hour the session will be there. But if required, I will extend the session. Okay. So yeah, Sakshi, that is why I'm telling you to start your preparation now only. Even though you haven't covered, we are there to help you, right? So because of this, you will be clearing. Okay? Yeah. So let us solve this. We are in the middle of it. So V minus T into dou V by dou T at constant pressure, right? So what we have volume, volume is given by RT by P. Let us go through this. RT by P plus B naught plus B1T plus B naught plus B1T minus T into dou V by dou T at constant P. So we have this dou V by dou T at constant P as R by P plus B1, right? Plus B naught plus B1T minus RT by P minus of B1T. So what you get? RT by P is cancelled, B1T is cancelled. So the answer is dou H by dou P at constant temperature is equal to B naught. Okay. So Sakshi, till this, did you got like how to solve, or like if you're maintaining a constant temperature, what to use? So you got this clearly, right? So what is B naught? B naught value is 4 into 10 power minus 5 meters cube per mole, right? So this is the value. So what is the question that they were discussing or that they wanted? So what is the change effect of uh, pressure on molar enthalpy and yeah, H at constant temperature. So this is what. So we got the answer. So the final answer is, and one more thing, they wanted us to determine what is change in enthalpy. So, Srikant, so for another half an hour session, this session will be like for another half an hour. Okay, means it is for from 11:30 to 12:30. So 1 hour session. Yeah. So delta H, so dH by dou P at constant temperature is equal to P naught, and yeah, so dH will be equal to B naught into dP, right? So if you integrate this, what you will be getting? Delta H is equal to B naught into PF minus PI at constant temperature. Here also temperature should be constant. Okay. So we have this B naught value and we also have initial pressure. So this is PI and this is PF, right? So we also have this P naught value. So by substituting this and by calculating, you will be able to get the answer. Okay? Yeah. So is that clear? Okay, I guess you are clear with this. So see, this question is like very big, but solution procedure is very simple. And so see, so first thing what you should do is you shouldn't like you should be you by just seeing the question you shouldn't be like this is a very big question, I cannot answer. Okay. Yeah. So next question. A binary mixture of components 1 and 2 forms an azeotrope at 130 degrees centigrade. So, yeah, we have an azeotrope. So, this is an different problem. So, what is an azeotrope? So, it is a condition where we have a maximum boiling condition. Means azeotrope means the mole fraction in gaseous state and the mole fraction of liquid in vapor state is the same. Okay, so for an azeotrope condition, you should know that we should use the condition that x is equal to y for a particular species. Okay. So for a particular species, you should use this, and yeah, means xi is equal to yi. So azeotrope means xi is equal to yi, but not xi is equal to x2. Okay. So it is not. It doesn't depend upon the individual mole fractions. It just depends on the mole fraction of individual species. Okay. Yeah. So we have a binary mixture and the mole fraction is given. So as they have given x1 is equal to 0.3, that means y1 is also equal to 0.3, right? Because this is an azeotrope. And yeah, the liquid phase non-ideality is described by ln gamma 1 is equal to ax2 square. So ln gamma 1 is equal to ax2 square and ln gamma 2 is equal to ax1 square. So gamma 1 and gamma 2 are activity coefficients, right? And we have x1 and x2 are the liquid phase mole fractions. Okay, so for both components, the fugacity coefficients. So we also have fugacity coefficients, which is phi 1 is equal to phi 2. It is given as 0.9. Okay, at the azeotropic composition. So this saturated vapor pressures means P1 saturated is equal to 70 bar and P2 saturated is equal to 30 bar. So for all this given data, we should calculate the total pressure in bars for the above azeotropic system up to 2 decimal places. Say they are mentioning about the decimal places till which you should calculate. Okay, so you should give the solution till that only. So if you got the answer as 15.111 and 15 point or 15.156 as the answer, and if they are asking about and if they are asking about see this two decimals, then you should give the answer as 15.16 but not as 15.15. Okay, so this will be a wrong answer and this will be the correct answer. Okay, so if we are having such type of questions, then uh, see they will not give the range. Okay, they will just give you the perfect, I mean the absolute answer. Okay, yeah, just a minute. So this is the data. Okay. So how can we calculate or how can we solve the question? So just tell me the idea. Oh, okay. Let me just solve this. Okay. So we have x1 is equal to y1, which is equal to zero point 0.3. And so if x1 y1 is zero point 0.3, then x2 comma y2 is equal to zero point 0.7, right? Yeah, and P1 saturated, as I said, first read the formula and write all the data given. P1 saturated is equal to 70 bar and P2 saturated is equal to 30 bar. Okay, and yeah, so ln gamma 1 is equal to ax2 square and ln gamma 2 is equal to ax1 square. Yeah, so we should calculate the total pressure. So how we can calculate this? By using modified Raoult's law. Okay, so by using modified Raoult's law, what is this? Pi 1 into phi into pi is equal to x1 gamma 1 p1 saturated. Okay, so this is the modified Raoult's law in which phi is fugacity coefficient and y is the mole fraction of a particular component and p is the total pressure of the system. And x1 is mole fraction in liquid state and this is mole fraction in gaseous state. Okay, so gamma 1 is activity coefficient and P1 saturated is a saturated vapor pressure at uh, of the particular component. Okay, yeah. So I hope I'm clear with the formula, right? So they have given that phi is the same in both the components, right? So from this, P can be given as x1 gamma 1 P1 saturated plus x2 P2 saturated into gamma 2. Okay. So we have X1 values and we have P1 saturated and P2 saturated, but we don't know what is gamma 1 and gamma 2, right? So how we can calculate this gamma 1, gamma 2? We have these relations, right? ln gamma 1 and ln gamma 2. So if you ln gamma 1 minus ln gamma 2 is equal to a into x2 square minus x1 square. So this is a mathematical property, right? Ln gamma 1 minus a minus b can be written as ln of a by b. So from this a into 0.7 whole square minus 0.23 whole square is given, right? So what we get? So what we get from this? So from this solution, gamma 1 by gamma 2 is equal to exponential of, okay, just wait a minute, ln of gamma is equal to a into 0.49 minus 0.09, right? So which is equal to a into 0.4. So we also have this gamma 1, we also don't know what is gamma 1 and gamma 2. So for calculating this, we will be using modified Raoult's law formula, okay? So y1 into phi into p is equal to x1 gamma 1 p1 saturated by y2 phi p by x2 gamma 2 into p2 saturated. Okay. So x1 is the same and y1 and y2 is the same. So I mean y1 and x1 is the same and y2 and x2 is the same. So we can neglect that, and phi is also the same, p is also the same. So which means gamma 1 by gamma 2 is equal to p2 saturated by p1 saturated. So what is the saturated pressure of second component? What we have? It is 30 by 70, which means 3 by 7. So substitute this value in this equation and get the value of A. Okay. So that means A is equal to ln of 3 by 7 by 0.4. So on calculating, you will be getting a value of A as minus of 2.1182. Okay. So this is the value of A, and yeah. So from now it is very simple. So you will be calculating gamma 1 with by substituting this A value in both the equations. Okay. So after that, gamma 1 is equal to exponential of A into x2 square, right? So it will be exponential of what we got A value minus 2.1182 minus 2.1182 into 0.09. So we get gamma value as 0.3542. Okay. Just check whether this calculations is correct or not. So, and similarly, exponential gamma 2 is equal to exponential of a into x1 square, which is exponential of minus of 2.1182 into 0.49. Okay. So from this we get the required answer, gamma 2, which is equal to 0.8264. So this is the value of gamma 2, and yeah. So for getting the total pressure of the system, we got now x1 value is there, gamma 1 is there, p1 is there. So we got all the values, right? So total pressure in the system is equal to x1 gamma 1 p1 saturated plus x2 gamma 2 p2 saturated. So by substituting the values, you will be getting a total pressure of 27.54 bars. Okay. So this is the answer, and yeah, I guess you are clear now. So any doubts regarding this question? Any doubts regarding this question, or any doubts regarding this thermodynamics topic? So if you have any doubts, please post your comment over here and I will answer you. I will answer you. Okay? Yeah. So it's a very simple problem. Just you should know that how to calculate and way to put all these calculations, right? So if you know that the relation between pressure, total pressure, and yeah, modified Raoult's law. So if you know all these things, then yeah, you will be doing it very easily. Okay. It's just that it takes a little time, but while doing calculations also be careful with it because everywhere we are doing this gamma 1, x1, gamma 2, x2, right? So there is a high chance of mistaking x1 as x2 and x2 as x1. Okay, so please do that. And yeah, so this is another problem. So basically, in this sessions, I'm selecting such a problem that with this explanation, just with the single explanation, you will get all types of concepts. Okay. So here in this question, we got to know what is Raoult's law and what is the relation between equilibrium pressure and activity coefficients, how we will calculate such problems, right? So it looks like it is a very big problem, but there is a chance of such questions because last time, if you see the question paper, it was very lengthy. So it was like when I saw the paper, I just thought that it was like a semester exam. So so you should prepare for the worst, and then if you see a very easy question, you'll be like, okay, so it's a very easy question, then we can solve that. Okay, yeah. So let's solve this next question. So what we have, carbon monoxide is burnt in presence of 200 percentage of excess pure oxygen and the flame temperature achieved is 2298 Kelvin. Okay, so we have this temperature and the pressure conditions, and we also have the how much amount of oxygen is used over here. Okay, yeah, and the inlet streams are at 25 degrees centigrade, and standard heat of formation data for CO and CO2 is also given. So the specific heat capacities are functions of temperature. So yeah, let us solve this. Okay. So what is the reaction? Carbon monoxide is burnt in the presence of oxygen. So when we do this CO plus half O2, it gives CO2, right? So this is the reaction regarding carbon monoxide. And so let us consider that a base. Okay, let us consider a base. So 1 mole of CO is burnt. Okay, so according to the stoichiometry of the reaction, for the complete conversion of carbon monoxide, so for 1 mole, it requires zero point 0.5 moles of oxygen to give 1 mole of CO2, right? So this is the stoichiometric coefficient. But what they have said is burnt in the presence of 200 percentage of excess pure oxygen. Okay, so O2 required is equal to, so generally what we require point for 1 mole we require zero point 0.5, but 200% excess means the required one, so zero point 0.5 plus 200% into the required one, right, which means 0.5 into 3, that is 1.5 moles of oxygen is taken. Okay, so clear with this calculation? So this is the main step involved here. So if you are clear with this, then the question will be very easily, we can solve this question very easily. Okay, so O2 required is this, and yeah, flame temperature. So they have given information about flame temperature and reaction temperature also, right? So we have standard heat of formation, but we need the data for standard heat of reaction, right? So delta HR is nothing but H of products minus reactants, right? So from this, we use what are the products? CO2. So delta H heat of formation of products is minus 390, and yeah. So for reactants, we have carbon monoxide and oxygen, but we have given only carbon monoxide. Why? Because oxygen is an atom, right? So this is not, that is the from oxygen only will form another component. So there will be no heat of formation, right? So minus of minus 110 minus 0 means minus 390 plus 110, which gives heat of reaction as 280 minus 280 kilojoules per mole, right? So delta HR is this, and yeah, this is the standard heat of reaction. And now what we have, what are they asking? The heat capacities of the components are this, and the heat loss per mole of CO burnt is. Okay. So heat of products, which will be integral of mCp dt, right, or ncp dt. So for so as they said, it is burnt in the presence of excess oxygen, means some amount of 200% is excess, right? Which means only whatever the required. So what do you mean by 200% is? Means in product also you have oxygen molecules, right? So product side you have to like heat of products for Q of oxygen plus Q of CO2. These are the products, right? So we have information about Cp of O2 and Cp of CO2. So after the reaction, as they said, 200% of excess, all the carbon monoxide will be burnt. Only oxygen will be present, that too on the product side, right? So this will be NCP of oxygen plus NCP of carbon dioxide dt. Okay, so from T1 to T2. So from this we get integral of, so what is the temperatures? 25 degrees centigrade, it is 298 Kelvin to 2298 Kelvin. Okay, the temperature should be in Kelvin, so don't forget this thing. And okay, so according to the stoichiometry, what are the number of moles present in the, number of moles of carbon dioxide present? So number of moles of carbon dioxide is 1, and number of moles of oxygen is 200 percentage of excess, which means 200 by 100 into zero point 0.5, which is 1, right? So yeah, Cp of O2, it is given as 25 plus 14 into 10 power minus 3 T plus uh, yeah, 1 into, this is for O2 and this is for CO2. Okay, so 25 plus 42 into 10 power minus 3 T dt. Okay, so integrate this equation. What you'll be getting? 25 into delta T plus 14 into 10 power minus 3 T squared by 2, and the limits are 298 to 2298 plus 25 into delta T plus 42 into 10 power minus 3 into T squared by 2, whose limits are 298 to 2298. Okay, so this is the heat of products, from heat that is ejected or absorbed in the product side. Okay, so QH on calculating, you will be getting the answer as 245.376 kilojoules per mole. Okay. So what is the heat loss? Heat loss will be delta H R minus of Q, okay, delta HR plus QH. This is nothing but 280 minus, so minus 280 plus 245.376. Okay, so what does that mean? 35.624 minus 34.624 kilojoules. As they have mentioned that it is a heat loss, then it will be minus of minus, which means 34.624 kilojoules. Okay, so this is how you solve such type of questions. I mean, how we solve these questions. Okay, so it is just that you have to know how to uh, like how to check the equation and how to know the number of molecules that are present. Okay, so if you know, if you get this data, and if you know that you should, heat loss means nothing but the summation of whatever the heat that is lost in heat reaction, I mean during the reaction, and whatever the heat that is provided in the product side. Okay, so if you know this, then you will be able to answer this question. So it is not that easy, but if you know the concept, then you'll be able to calculate such type of questions. Okay, so basically this is from chemical process calculations. So as this is a part of thermodynamics, I just wanted to give, I mean explain one question regarding this topic. Okay, so I guess you are clear with the data, and if you have any doubts, please comment. And yeah, so one more thing. Um, so if you want more information, like regarding thermodynamics or regarding heat transfer or any other topics from, not only for chemical engineering, so Unacademy have various branches. So we are taking courses for, we are launching courses for various branches also. Like it's for chemical, whether it is mechanical or civil, electrical, ECE, and also CSE. So we have courses for chemical and mechanical, civil, electrical, ECE, and CSE. So we also launched pre-mock tests for students for different branches. And yeah, so pre-mock test will be very limited. But if you take the plus subscription, then you'll have a lot of mock tests to attend. Okay? Yeah. So I hope you guys are clear with this, right? Yeah. So if you want to take the subscription, uh, go to an Academy app, and yeah. So go to Unacademy app. I mean, go to Play Store, install Unacademy app, and take the subscription. So we have courses. I mean, we have 3 months subscription, 12 months subscription, and 24 months, which is for 2 years course. So as Sakshi is preparing from like second year, so she, if you want, you can take for 2 years course, right? So yeah. Um, and if you want to take the subscription, if you are a new subscriber, then do use my code Padma10. So you will be getting a discount only if you are a new subscriber. Okay. So yeah. So why to waste the time? Avail the benefit, and yeah, clear you. So here you can clear your doubts also. Yeah. So another question. So I will just explain the question, like what is the basic concept that we will be using here. Okay. Or if you have any doubts, we can discuss that also. So I think it will be better if you guys solve this problem, and if you comment, I mean, if you give in the comment section. Okay. So give me the answer in the comment section. So I'll just explain the topic, like what they were asking and what is the data that we have. Okay. Yeah. So this is a binary liquid mixture, means we have two components, and it is at equilibrium with its vapor at 25 degrees centigrade. Okay. So we also have this Antony equation for the system, which is given as, so here we have relation between pressure and temperature, which is given by Antony's equation, and these constants for particular components A, B, C, the values are also given. This is for component 1 and this is for component 2. Okay. So the vapor phase is assumed to be ideal and the activity coefficient gamma I for the non-ideal liquid phase are given. So gamma, as I told in the before problem, we have gamma 1 and gamma 2. It is related with mole fraction x1 and x2 in this with this equation. Okay. So if the mole fraction of the component in liquid phase is x1 is equal to 0.11, then the mole fraction of the component in of the liquid in vapor phase by 1 is. This is a very easy problem. So I will just tell you the gist. I will just tell you how to solve this problem. Okay. So the main, I will not solve the full problem. I will just tell you how. Okay. So by using this log P, log to the base 10, P saturated is equal to A minus B by T plus C. Right. So we have values of A, B and C also. So they have given x1 is equal to 0.11. So that means x2 is equal to 0.89, right? And we also have ln gamma 1 and as a function of x1 gamma x2 and ln gamma 2 as a function of x1 gamma x2. Okay. So these are the data that we have. So to calculate y1, it is a very simple. See, with this x1 and x2 values, whatever we got, we can calculate gamma 1 and gamma 2, right? So then gamma 1 will be exponential of x1 square, uh, sorry, x2 square into 2 minus 0.6 x1, 2 minus 0.6 x1, right? So we know what is x1 and what is x2. So from this you can calculate gamma 1 value, and similarly from this equation we can calculate gamma 2, which is exponential of x1 square into 1.7 plus 0.6 x2, right? So from this you will be calculating x2, and we also have this modified Raoult's law, which is y1 into p is equal to x1 gamma 1 p1 saturated, right? So by using this formula, you can calculate, you can even do the further calculations. Okay. So again, we don't know what is the total pressure maintained in the system. So how can we get this? So we know Y2P is equal to X2 gamma 2 P2 saturated. So if you add these two things, what you will be getting? P value, right? Which means Y1 can be given as X1 gamma 1 P1 saturated by P. And this pressure is nothing but X1 gamma 1 P1 saturated by x1 gamma 1 P1 saturated plus x2 gamma 2 P2 saturated. Okay. This is a very simple problem if you compare with before previous problems, right? So we know all this x1 and x2 values, and we also have gamma 1, gamma 2 and P1 saturated and P2 saturated. Okay. So from the given data, you can solve the question. So if you find any problems regarding this question, just put a comment in the comment section. Okay. So I would expect you to solve this question and give the answer, right? So yeah, this is about today's session. So yeah, if you have any doubts, you can post your comments. And so for more information like this, or for more courses and quiz sessions and analysis sessions as such, if you wanted more, go to Take Plus subscription, install the Unacademy app, and take the Plus subscription. So yeah, so if you are a new subscriber, use this code Padma10 and you'll be getting a 10% discount on the whole amount whatever you are paying. Okay? Yeah. So we have special offers for 3 months and 12 months and 24 months. So if you take as a year wise or 3 months wise or 2 years wise, you'll be I mean the amount that you are paying will be reduced, and on that again 10% discount will be there. Okay, yeah, I suggest you guys to take the subscription. And yeah, so hope you guys prepare well for the session, well for the gate exam. And as today is the end of the 2019 year, so I hope you guys have a great year ahead and wish you a happy new year. So yeah, and if it is a new year, we are approaching for our exam. So we are approaching to our target, right? So be focused and stay tuned to all the sessions that whatever we are taking. Okay? Yeah. Have a good day, guys.